All right, verify this identity. So, where do we start with this one? That's always the challenge. And sometimes you just got to do something. Just do something. Um, Now, when I look at this, I see, okay, I got two fractions. Do I want to try to combine those fractions? That might work out nicely because I see this 1 plus cosine theta and this 1 minus sine, or 1 minus cosine of theta. And I know if I put these on a common denominator, that I'll end up with 1 minus cosine squared in the denominator, right? So what I'm going to do is just rewrite these two fractions on the left-hand side and just make them have a common denominator. And I'm going to do that by taking the first one and multiplying by 1 minus cosine of theta over 1 minus cosine of theta. That's just 1, so I'm not changing anything. I can do that as long as I'm not changing the expression, right? And then I'm going to multiply that times 1 plus cosine of theta. All right. And then we have this 1 minus cosine of theta. Okay. Now, if I want this to have a common denominator, I need to multiply by 1, but it's going to be 1 expressed as 1 plus cosine of theta over 1 plus cosine of theta. Okay. And I'm asking, is that equal to 2 plus 2 cotangent squared of theta? All right, but remember, I can only work on one side. So what I've done here is just multiply by 1. It doesn't change anything. So this left-hand side is going to be equivalent to what I had before. But it's going to allow me to combine those two fractions. Okay, so I end up with 1 minus cosine of theta over 1 minus cosine theta times 1 plus cosine theta is 1 minus cosine squared of theta. Okay, so that's the factorization for the difference of two squares. So I can just rewrite it that way. This other on the left-hand side of the plus, or sorry, the right-hand side of the plus, this becomes 1 plus cosine of theta all over 1 minus cosine squared of theta, right? Because this is the factorization of the difference of two squares. Now I have this these two fractions with a common denominator, so I can add the numerators. So when I add 1 minus cosine to 1 plus cosine, those cosines will go away, and what I'm left with is 2 in the numerator, and then the common denominator is 1 minus cosine squared of theta, which is sine squared of theta. So let's rewrite that as 2 over sine squared of theta. Okay, now I'm forgetting to copy this all down here to cotangent squared theta. All right, this is what I'm testing, so I should probably copy these down. Cotangent squared theta. We're testing, is that equal? We're always trying to test if this is equal to 2 plus 2 cotangent squared of theta. Okay, so again, I haven't quite proved it yet. But, okay, so I know that 2 over sine squared theta, I know that 1 over sine squared theta is cosecant, right? That's cosecant, so, or cosecant squared, right? So I can rewrite this as 2 cosecant squared of theta. Now that still doesn't look like 2 plus 2 cotangent squared of theta, okay? But if you remember the Pythagorean identities, I know that there's a Pythagorean identity that, whoops, that was supposed to be cotangent squared. I know there's a Pythagorean identity that involves cosecant and cotangent. All right. Now, do I remember what that is? If I don't remember what it is, what I always do is just, okay, let's do a little side calculation here. I know that sine squared plus cosine squared of theta is equal to 1. Whoops. Control C. All right, is equal to, what happened to my pen? All right, equals 1. All right, now cosecant is 1 over sine. So if I divide everything on both sides by sine squared theta, right? sine squared theta. Sine squared theta. That gives me 1 plus cotangent, cotangent squared of theta is equal to cosecant squared of theta. All right, so now I can do a substitution. Let me scroll down a little bit here, give myself a little more room. So I can substitute the cosecant squared theta with 1 plus cotangent squared theta. Okay, now you can kind of see what's happening here. Cotangent squared theta. All right, so if I distribute the 2, I get 2 plus 2 cotangent squared theta is equal to 2 plus 2 cotangent squared theta. QED, right? That's it. That's what I wanted to prove. I'm done. All right, so I think that's the last example. That's the last example for this lecture. That's a lot of examples. But hopefully that gives you sort of a flavor of the sorts of things that you might think about doing as you're verifying identities, because you're going to have to do some of these yourself. A lot of algebra involved in this, so I gotta brush up on your algebra skills. All right, well, that's all I have for the lecture today, and I will see you in class.